and we'll know that in a few seconds. All right, so we'll give it a couple of minutes just to get confirmation that it's all working. Yep, it did give me notification, and I can see that we're live. That's awesome. All right, so what I usually do for a minute or two, so that people start logging in, Andrew, I wait a little bit and make sure that people are having the time to access. So we'll give it just a minute or so. And in the meantime, Alex is confirming that we're live. Can you go ahead, Andrew, and just say anything for now to confirm that they can hear you and they can hear me as well?
Yeah, glad to be on live with the, what do you call this? The 30 days live?
Composites A to Z.
Composites A to Z, 30 days live. So excited to be here. Had an opportunity to view a lot of these, and it's great to be on it and participating. And I'm excited about going through a few things today and talking basically on a lot of questions and conversation, along with some information, and kind of going through certifications for composites, materials, and products. I'm Andrew Polkowalt with the American Composites Manufacturers Association.
All right, this is awesome. So yes, it is. I got all confirmations that everything is working, so we can actually go ahead and get started. So, Andrew, I am so excited to have you for two reasons. One of them is Acma, ACMA is with SAMPI. They are the two communities behind CAMEX, and I'm one of CAMEX co-chairs, and this is, for me, SAMPI and CAMEX are the go-to conferences in my field. I just love going there because I meet everyone I know that I work with. We have discussions, and this is awesome. So that's the first one. The second one is because although I like to call myself a composites expert, I know that I lack knowledge when it comes to so after I design them and I manufacture them, I know what's required for certification, but this is where it stops. So for me, this is a learning moment as well, and I'm looking forward for it.
Okay.
All right, so I can see that people are hearing us. I have several people saying hello and good morning, hello. I even have a message for you, Andrew. Someone named Di Posey saying, "Tell Jesse Smith I said hi." So later,
All right.
later you can see those messages. All right. So Andrew, you already introduced yourself. You're the director of certifications within ACMA, the American Composites Manufacturers Association, and we're going to talk about composite certification. So let's go ahead and get started about the certification of a material or product versus recommended standard or compliance. What's that about?
Okay, so different composite materials and different products have to be certified for different uses. And you can kind of see on the slide here, and we'll talk more about as we go forward, that testing and certified of a product needs to be in conformance with a standard. Now, that standard in composites is often going to be different depending on what that material is going into or what the final product is. Compliance is usually done by a certification of a third party. So there is requirements for that material or product certification to have it in compliance with the requirements needed for whatever the application is. And we'll go a little bit more into that, but keep in mind that what's required for a composite material or part to be put on an aircraft and what's required for a composite material or part to be put on a building are going to be different, and there's going to be different certification standards.
So to summarize what you said and to make sure that I'm getting it right, basically I can claim I'm compliant to a standard if I'm manufacturing it. This is internal process, and I say, hey, I am compliant. This is up to standard. and let's say you as a third party, you can certify my assessment that I'm compliant.
That is correct. There's a third party that's certifying. Now, ACMA in particular, we do not certify products. I work with certifying personnel that are doing technical composite stuff, but we work all the time on the standards that meet those certifications and getting the certification bodies or the government agencies or other people that are certifying things to better understand the products. And we'll talk more about that later on, but also it's a good thing to keep in mind that often we're trying to certify products in composites into markets that have traditionally used other materials.
Yeah, I mean the wave moving from metals to composites for all of, I mean, this whole month was, we need composites. They have so many advantages, but there is so many hiccups along the way, and one of them is knowing how we can manufacture them. We had a great lecture yesterday with CG Tech and saying you get to pick. You don't get to pick. You have to choose if you want gaps or overlap. You get to choose one of them, and each one will have influence on manufacturing and whatnot. So when it comes to composite materials qualifications, you're talking about the level of structural complexity, and there is a listing of different elements. So do I understand your listing as there is a certification for the constituents on their own, there is a certification for the lamina, so a single ply, there is a certification for the laminate, and so on? Is this, my understanding is correct?
It is correct. And kind of using this slide and going through, I can just give you a couple examples. A constituent material would mean that it's a resin system or a reinforcement system that is going to get certified to be used for a certain application. The lamina and the laminate is what you commonly at your level are working with and see a lot of, but people are very familiar with the certifications for laminate because that's a lot of the standard ASTM testing standards that are done when you're trying to qualify a material or give the requirements for a material are what fall under the lamina or laminate. And then a structural element, you're moving into making it into a part. That kind of goes with your lecture yesterday.
Yes.
And how you design that and set it up so that it can be confirmed that that actually certifies as a proper way to put together and design the actual part. And then the subcomponents and components are after you make that part, how is it integrated into what? It could be different for a car certifying a part than a plane certifying a part, but it's still the same thing for the components and subcomponents. So it builds on itself, but.
So in some sense, a component is the aircraft, a structural subcomponent is the wing, a structural element is a portion of that. Is that somewhat what it is?
That's somewhat what it is.
Is this the pyramid?
Correct. That component might not be the whole aircraft. It might just be an aileron and the pieces attached to it. But yes, you're absolutely right in saying it that way.
So let me ask you a question. Once I visited Gulfstream and I saw this wing flex testing where they flex the wing of the aircraft. It felt like a horror movie for me.
Yes.
I was like, why are you doing this to an aircraft? So is this a component level testing?
That would be a component level testing. That's the part that's actually going to end up on the aircraft being tested to make sure that that component has certified and met the requirements to be put on the aircraft.
All right. So you often, I mean, so far in the discussion, you've emphasized it so much that certification and qualification vary by market and by the usage of composite. I can totally understand that. I mean, when we manufacture stuff for space applications, we are in this clean room environment and so many. Talk to us a little bit more about the process.
Yeah. No matter what you're manufacturing, you always have to have the components or the manufacturing process and the qualifications for certifications set up within the requirements for what it's going to be used in. And your space example is a great one, because that's a space to me when I'm dealing with people using materials for space applications. They have all different problems with temperatures and using them in environments that are just so harsh compared to what you're ever going to have a car apply to. But automotive certifications are also looking at a lot of different things on the safety side and the longevity side, because your car and its components and materials have to hold up over time. Depending on how critical the component is what the requirements are for it. So obviously something that's in a brake system is going to be a lot more concerning than a cosmetic part on a interior panel somewhere on a car. Whereas in an aircraft, you're going to have certifications on interior parts too, because there's even stricter requirements for fire, smoke, and toxicity that are taken into place. So the material and the application are always what you're certifying to. To get the composites into certain markets, one of the things that ACMA works a lot on now, and we have one of our vice presidents that spends a good amount of his time working on standards to try to get products to certify and meet the requirements for applications in infrastructure. Different infrastructure applications have different requirements. Is it inside the building? Is it on the facing of the building? Is it a structural component of the building? You're going to have to meet other requirements depending on what the load is going to be on it and how it's going to be exposed to people or the outside environment.
Okay, I can totally see that. There's one thing on the slide I'm trying to wrap my head on. What's the difference between when you put general aviation and commercial aviation?
Big difference in general aviation and commercial aviation is FAA and other requirements for general aviation, if you're not flying passengers, are different for the aircraft and the requirements for the parts on them. So if Andrew is building a plane in his barn that he's going to fly with just himself and one friend who's daring enough to go up with him in something that he built, the requirements are different than if I'm going to have a plane that I'm flying people commercially on.
All right, I do have a follow-up question on this. Is Andrew building an airplane in his garage?
He is not currently building an airplane in my garage. I am working on some parts for a go-kart for my kids, but I try to work on my composite parts at a little smaller scale. I'm not qualified to fly an airplane, so I'm not building one right now. But I do know some people that are doing that.
I do know as well. I just felt it the spur of the moment to ask you this. So talking about flammability standards and certifications for composite materials.
Yeah.
What is it that we're looking at?
So what the material application is going to be in is going to make the qualifications and certifications that you have to meet with that material adjust. If you look at the examples here, a lot of people are familiar with UL or Underwriters Laboratory for consumer products. That's often a certification that people are going for if it's something that's going to be sold to consumers. You also see the ASTM, NFPA restriction or qualifications and certifications on there. That's often for building materials and how the standards are set up. There's some rail qualifications on there that you would be meeting to certify that product for use on a rail line or rail cars. Also FAA is for aircraft that we've kind of talked about. And then fire test procedures are often set up for commercial shipping and ships. Also, those are often brought over to a D2D standard that's used by the Navy for ships that they have. A lot of work's been done over the years on that to get qualified composites into naval craft too. All
right. Does the FAA refer to ASTM standards sometimes, or are they completely separate?
No, they are connected because those materials you have to, in the FAA situation, you have to qualify the material before it can even be used to make the part. And a lot of this ASTM qualifications are used to do the material qualification to begin with. And we'll talk a little bit more about that. And that process is pretty extensive if you want to qualify a new material for aircraft.
So what is ACMA's involvement in material certifications?
So our involvement in material certifications is multiple different things, but our first thing is we convene professionals throughout the industry to set up FRP or fiber reinforced polymer guidelines and recommendations. We also work with a bunch of different councils that we have throughout our membership that are working on ways to qualify materials and introduce materials to meet the standards that are out there for applications in different markets. So maybe it'll be expanding what's used in automotive to different areas of the automotive supply chain, or using it in other operations in trains or passenger buses or other things. Another example of that is what I talked about, infrastructure. We do a lot with that. Ways that we can use the current existing certifications and qualifications for materials and fit and make it applicable so that composites can be used as a product in those particular things.
So talk to me a little bit about this bullet, certification for personnel in manufacturing. Do you like run courses on this? So I do, and I've referred it several times this month. I did use some elements from your basic composites handbook, and every time we use that, like we made sure to reference it. I mean, it's a wonderful resource for getting started. Let me ask it this way. If, let's say, I want to be certified for design and fabrication in composites, is this like something you come over to McNair and do the certification? Do I go somewhere? How does it work?
There is a few options. We can come to someone and do certifications and training that's connected with that to become certified composites technicians. Sometimes those are used as stackable certifications for people working in engineering. Sometimes it's just technicians that are working on it, or designers or other people. But we also have the option to do things remotely for people that have some experience and want to meet a certification standard for personnel. And also I have an instructor network of folks that are all over the country that are instructors in the Certified Composite Technician program. So often they'll be delivering some of that training and the certification testing at different locations also.
Okay, so is this an example of the certifications you guys support for corrosion applications in various markets?
In this case, corrosion is one of our personnel certifications, but corrosion is various markets that we're always working on bringing composites into, because as you know, and I know you've talked about before, some of the properties of composites for corrosion resistance are incredible and bring a lot of advantages. But it isn't just for one market. It might be pipe, tank, oil and gas, but it also can be things that are used in aviation, because the corrosive properties are good in naval applications and offshore applications, along with other products that require corrosion resistance, not just to standard chemicals that we're dealing with, but maybe in chemical refining or other harsh chemical mining environments and other things where that's a big application for composites. And it also requires certification, because nobody wants to put thousands of gallons of hydrochloric acid in a tank that people have not certified as safe to hold that material.
Yeah, I hope so.
Yeah, so that is a large market.
So what about aerospace composite certification standards? I see on the top the one that I'm really familiar with, FAA Part 21.
Yes.
What about tell us a little bit about it, and tell us a little bit about all the other ones.
Yeah, so the FAA Part 21 certification procedures for products and parts is how those products and and parts are certified to be put on aircraft to begin with in commercial aircraft through the FAA. And if you look at the bottom of this slide, there's also ESA is on there. A lot of the qualifications for FAA parts and aircraft are also done by ESA, and they intermix sometimes depending on what the application is, but they also have a certifying body for that. But some of the other ones are standards and certifications for particular applications or particular part standards that have to be met along the way. There's lots of work constantly being done. SAE has a lot of standards that are used in aerospace, and then the Mill Handbook 17 or CMH 17 material is normally what is always done by the U.S. Department of Defense to qualify materials to be on military aircraft, and other composites applications in the Department of Defense of the United States also follow some of those standards because they're generally accepted throughout that community.
Yeah, so two things I want to say. First of all, SAE are awesome because they are my publisher. I published my I published my textbook, the first textbook I ever wrote, Introduction to Advanced Manufacturing, last year, and they are my publisher. So shout out to them. And the second one is we did a lot of work in the NASA's Advanced Composites Consortium relevant to reduction of certification timeline. And I can see where we've used sometimes ASTM standards, but we had to adapt them because the standard. So we had this project relevant to plasma treatment of AFP manufactured coupons, and there is no verbatim standard written for what we have done. So we had to take some of these ASTM standards and appropriate them and adjust them to the case study that we have.
Yeah. In aircraft, you always hear people, obviously the people in the composites industry that have been around a lot longer than me, a lot of them were metallurgists initially and then came into composites, but you hear people throw around that term black aluminum. That's not always the best application for composites, just taking out an aluminum part and replacing it with composites. But sometimes, even if you're not doing that, you're still sort of forced to use some of those standards that were already around for metals to make sure that your composite product meets the requirements to be certified and qualified, especially in aircraft.
Yeah, and in our case, it was a certification standard for polymers without reinforcement, and we adapted it to, hey, now it's no longer just a polymer. It has it's more of it's more of the metric and the standard and the methodology that was used, but the numbers were changed to more suit comparison. And I will, this is so interesting. If I thought of it before, I would have prepared it and uploaded that video, and I would have played it at the end because it fits perfectly the discussion we're having. So
how you use that
yes.
methodology to qualify?
Yes. So we're talking now about materials and part certifications for aerospace. So I see you have 3 columns, 3 separate entities. Talk to us a little bit more about this.
Yeah. So broke it down because, especially in aerospace, the process is usually quite long and challenging if you're going to start with a brand new material. So on the far left column there, you're looking at materials certifications, which if you're going to certify a new material, you're going to lengthen the process to certify the part or the application to actually get it into work by quite a bit. That's why even in some newer programs, sometimes people use a pre-qualified and certified material because that's challenging. In the aerospace industry, it is very challenging, more so than almost anything else. Sometimes people that are running startups and have great ideas and are working on something can get a little frustrated by that. But if it's in other applications, it's a little bit easier. The next thing is part design and development, and that kind of falls into some of the stuff that you were talking about, where you were trying to develop a material to be used in a different part application. So when reinforcement was put into it, you had to get it certified and qualified to be used differently and to probably carry, I would assume, heavier loads because it is reinforced. And that's usually the advantage to reinforcing things and make them into a composite. So that's the second category that you kind of see on there. And then the next thing is talking about verification and applications for aircraft industries. And that is when the actual part from that earlier graph, when you get to a higher level and you're actually qualifying and certifying a part or a component and some of the things that you'd be doing to make that happen.
Can you let me know an example of weathering? I imagine weathering is like you're subjecting it to harsh weather conditions.
Correct.
Can you give me an example of that on an aircraft? What would we do?
Yeah. So for a material that's going to be neat, that has weathering as one of the qualifications or something that has to be done to make sure it lasts, it might be put into some kind of chamber at a test facility of some kind. The NASA example you gave is a good one for that because it's not just weathering, it's weathering outside the environment of the Earth, dealing with really, really high and really, really low temperatures, temperature changes, exposure to ultraviolet light and other things. That can all be done. Initially, it's usually done in some kind of controlled chamber where they put it over time, but not over as much time as would be 20 years of weathering, but they accelerate it by taking the exposure in some kind of chamber that they can do that in. Different applications have different standards that need to be met, but they might have to be run through several tests on the same material. There might be one test regimen that's done for ultraviolet light, and then another one might be done for temperature or humidity exposure at various temperatures. So that would be kind of the weathering side of things that would be done. Weathering is probably an easier term than the many things that it goes through to meet those requirements.
I have a question. How
Yeah.
much of these digital advances in digital manufacturing can actually help reduce certification timelines? So I often use the example saying, I mean, if you have a pressure vessel somewhere in the orbit, most of the time you put another one, another physical one on Earth, and you put it under the same condition and you accelerate those conditions a little bit just to know when something might happen. How much are we from like skipping having to do such things and using some digital algorithms, like, you know, like getting sensors on board of the actual physical thing and transferring data and analyzing it? How far are we from this concept that we talk about now into actually putting it into practice and, you know, like in real practice?
Well, some of it is put into practice now, especially with the database materials that are out there from previous testing. Now that can be put into formulas and the data is kept along the way, some of it can be accelerated because if they're using a known material that's been exposed before, they can already apply some of that to a particular, in the composites case, I say the material and resin system might have already been tested for some of those conditions, and they can use some of that data that's already out there on that particular thing, so they can accelerate to the next step where they're actually putting it into a component of some kind and doing additional testing. And then once things are in a component, that's a great point you brought up. If with some of the digital technologies out there now, sometimes we embed sensors right into the composite or on the component, interior to the component, so the testing can be done. And that data is also collected much more efficiently than it was just 5 years ago, but way more efficiently than it used to be 20 years ago, because before we had those sensors and that technology and the data sets and computer power to be working with those data sets efficiently, no one really could do that without doing a different test each time. In the case of us today, if you think about the simulation software that you can put on your desktop of a laptop now or a desktop computer, and what you could get 20 years ago, it's not even in the same ballpark. You can access data sets that people took years and years to put together, and it's already in the simulation software. So it does cut down that time significantly. But to get certified and certify the material, you also have to have a good record of how you did that, what data you were using, and really prove that to the certifying authority, especially in aircraft.
Yeah, there's so many people putting messages such as Internet of Things and so on, and there's so many hellos. Hello, everyone, and thank you so much for tuning in this excellent discussion so far. So we're going to be moving to automotive composite certification. Which one of these agencies is the equivalent of FAA for? Is it the FMVSS or another one?
It's really the Department of Transportation is really the people that are in charge of that as an FAA level, but FMVSS is doing standards that are used for those certifications and qualifications, so they're mentioned in there also. But again, back to SAE, since I know you like SAE, but they have a lot of standards for automotive.
I'm sure they are the best.
Started. Yes. So they put a lot of those together along the way. And, that's referenced by even the stuff that we do now. People are using known test methods and standards to meet those requirements in automotive. Now, automotive requirements are a little bit different than aerospace, but a lot of them are still pretty strict in a lot of different ways, mostly because the liability and the volumes used in automotive change some of the equations on how you want to certify things and what's needed, because there's so many people in automotive that are using cars when they get out there. Big one, though, that we talked about earlier that's pretty applicable is material longevity, and how it's going to hold up in working conditions all the time.
This is one of the major reasons why we switched to composites, is this corrosion. There's so many different levels of properties actually, and you can correct me if I say it wrong. There is a number that I've read somewhere, I forgot where, that even aircraft recertification or so on move from like every 7 years to 12 years. Go ahead, correct me. What is this number that's coming a little bit in the back of my head?
Yeah, the process, if you're new aircraft certification, that's where that moved to 7 years from 12, but that's only if people meet the particular milestones that they need and can move forward at that speed. Yeah, so automotive is kind of the same way. And some of this has to do with there's large automotive OEMs, and nobody's going to tool a factory and commit to stuff unless they have a good plan. But, that's sometimes testing for new product development is out 5 or more years. I think it's 7 years was the average, and they're trying to bring that down to 5. But it is the same thing with that. Sometimes market conditions or problems with certifying or qualifying a new design or material can lengthen the time if it's not done properly.
All right, and I see there's also other standards for architect. I got, if you want, like from your discussion, I think I've learned this very, very clearly, that composite certification is domain dependent. And if you are aerospace, if you are automotive, if you are architectural and infrastructure, you have different governing agencies, you have different standards, you have different, if you want to be compliant on your own, you have different standards that you need to look for.
Absolutely. So just because you've designed a part that is used on an aircraft doesn't mean that it automatically is going to get accepted in a different market. There's a better chance, if you met those aircraft specifications, that you can be accepted in an infrastructure application, but you sure better be using the certifications and standards that the construction industry is following, because if you go in and talk about FAA qualifications on a material that you're trying to put in a building structural beam, you're not really going to get the reaction that you want from those people that you're trying to get that product into their market. That's not where they live.
Unless we are in year 2200 and our buildings are now flying buildings.
Yes. And
Right,
there's some things that matter more depending on how the product's used.
I totally get the point, and it's awesome because it comes through so clearly to me. And this is something that as we were preparing the lecture, me and you, I told you this is something that I know a bit, but not that much. And now it's super clear in my head, and I'm gonna take it to my classroom myself. So, all right. So, talk to us a little bit about TRL levels examples, and this. I think this is a Boeing classification.
Yes, I actually, Boeing had this in a bunch of the materials that they have, and I borrowed it from them, but it's not just used by them. Technology readiness levels are a common term that's used mostly in aerospace and automotive is where it's dictated along the way, but different people are on a different area of the thermometer in this case, and that's why I kind of like this, because everybody can sort of see where you're going with it and how you move up the technology readiness levels. But initially, it kind of goes back to one of the early slides and discussions we had with, okay, you're going to start with the material at the bottom. What are those constituents that make up the composite material, and how are they prepared and tested, and what requirements have they made? And then as you move up in technology readiness level, you're going to the components, and then you're looking at, okay, how is this going to be used, and how far or what else has to be done before it can actually become a technology that's deployed. You're really trying to get to the highest level and deploy the technology in whatever application it is. You'll see these, or they're referred to often in aerospace and automotive applications. And you might be talking, somebody will say technology readiness level, and they're working in a university lab, and somebody might say technology readiness level, and they're working in a safety testing facility for an automotive maker. They are on different levels, but they're all kind of trying to get to the same place where the product is actually ready to be deployed and certified and qualified to be used.
Basically, TRL1 is when you're starting, you're thinking, you're doing basic research.
Yes.
And as you move up, you try to get out of the TRL9, which means you've launched, you've tested, and you're done. Yes. Once you graduate from these levels, this is basically when your example makes it to the market, right?
Correct. And usually, especially if the financiers are smart, that product's going to make it to the market when you made it through all the levels. So they don't only want to know that you came up with a great product. They want to know that you can actually manufacture it, and it's within a cost level that there's a market for it. Sometimes the greatest materials are not necessarily something people can afford.
Yeah, I always say to my manufacturing class, I mean, you can manufacture, you can design your holes, all of them, to be square. You can manufacture them also to be square. I mean, there are processes, but at what cost? So unless you really need it, why don't you just do it circular like everyone else, and a simple mechanical joints can fit? So cost is always part of the game.
Yeah, you have to make it so they're not going to have to retool the whole factory to do square holes. There's a lot of things that would have to change too.
So I actually 1 year, 2 or 3 years ago, I gave the example, and then one of the students told me, "Hey, they made a new machine that can drill square holes in Japan," and he showed me the video, and I'm like, "All right, I learned something." All right, so certification requires various requirements. So this is a little bit the summary of your certification. So why don't you take us through it?
Yeah, it's not a one-size-fits-all certification for materials. think ahead of time, especially in the case of your students, this is part of it, but really anybody who's a designer or engineer that's coming up with a new material or wants to apply a known material to something else, what are the requirements for that market and how are you going to get it there? A great composite part in one industry might not be a great composite part in another industry. Another thing is they're extremely versatile, but sometimes the existing standards are restrictive. And we find this often in infrastructure applications. You're trying to meet a certification standard that was designed in the 1950s when people were building everything with steel and concrete. So it doesn't exactly favor the versatility of your material. It is really set up for a material that doesn't have any of that versatility. So sometimes you have to adapt while using existing standards. Sometimes you could take advantage in infrastructure, you could take advantage of the fact that there's building standards for localities and states and other things that also, if you have the proper testing data, you can fit within those standards. And we've had some stories of our members that have been very successful in that. But you can do that in any industry. Make sure you know where you're trying to get it sold at and are putting together the correct data. Sometimes the data is there, sometimes the tests are there, but you have to have the right combination of them to prove and certify that that product can be used for that particular application. And that's the key, knowing what you're going to do, why you want to get the product into that market. And also in between, the world I live in every day is at manufacturers and teaching people how to fabricate and manufacture things. Kind of goes back to you with the drilling square holes or whatever it may be. Make sure that you're not doing something that's so out there that you're never going to be able to get enough volume of the product made or get anybody that can make it because it's so expensive to change their process.
All right, this has been awesome. I guess this is a perfect conclusion. I'm gonna go ask everyone on LinkedIn to give a round of applause, virtual round of applause for this session. This is great. There's so many questions. I'm gonna try to go through a couple of them right now. I have Krishna who's asking, can you please explain some of the gaps about the role of 3D stitched preforms based composite and their certification? So I think they're talking about stitching of preforms. If you can talk a little bit about that.
Yeah, so in a lot of applications that people are trying to use stitched preforms now, they're trying to bring those products that are stitched into actual markets where they aren't used to having a stitched preform used. So some of that overlap or other things that are done in the specifications for parts are not something that's been previously certified or designed in that way. So they have to not only make the product to begin with stitch, but they'll have to do additional testing if they're trying to get it in an application where a designed overlap or a design bonding sequence is already in the product certification. Aerospace is a great example of that, where it's some of the 3D stitch stuff is really efficient and it can do some great things and it has the proper strength, but people aren't going to switch to it unless you can show that you have the qualifications and requirements to get that product out there in the way that it needs to be tested and certified.
Thank you so much. Andrew, this has been super awesome. There is another question from Imani. She's asking if you're willing to share the slides with them. So what I'm gonna do is actually I'm gonna show Imani something. The slides, everything is already on the archive page. So if you go to LinkedIn and you go on under day 24, you can already see two things. You can already see the slides that Andrew shared with us, and as well as you can see a link to Andrew's LinkedIn profile if you want to get more in touch. And once we're finished with this live stream, I will upload the link in here. The way to access it is you go to LinkedIn, and you go to My Profile. And within My Profile, under Featured, you have this Composites A to Z archival. This is where, at the end of every lecture, I go ahead and put all the information as needed. All right, so Andrew, we're going to wrap it up. Any final word that you would like to share with everyone?
Hey, thank you for getting me involved. I enjoyed it. And if people have questions, I'm glad to answer them or can assist them on stuff. Maybe someday I'll be allowed out of the house and I can probably run into some of these folks and answer some of the questions in person at different places. But for right now, be glad to do that. And hey, thank you very much. I enjoyed it.
I enjoyed it very much. We are all in this together. We are all trying to make the best out of it. And thank you so much, Andrew, for joining me today. And we're going to go ahead. Thank you, folks. So tomorrow we have so Andrew was asking me a little bit earlier, did I plan all these 30 days? I did not, but it is turning to be something impressive. I mean, just the fact that we're talking with Andrew, and yesterday we talked with Andre, last week was Sanesh from Convergent. Tomorrow we have another special guest from NASA, Jake Turey. So tomorrow we're going to be talking with Jake on a case study of AFP, and it's going to continue all the way till next week. We have so many awesome lineup to wrap up this awesome month. Andrew, thank you so much once again, and hope to see you anytime very soon, in CAMEX, hopefully.
All right. Thank you. Look forward to it.
Bye-bye, Andrew. Bye, everyone, and
Bye.
thank you so much for tuning in today.